Hello and welcome to the OCR Pure Core videos. This is Vectors 5 Lines and Planes, and this is 5.1, the perpendicular distance from a point to a plane. So if we look at this equation here, this is given to you in the formula book. The proof for this is beyond the specification, but you can look it up if you wish to. So what we're trying to find here is the perpendicular distance from this point to the plane. That's because the perpendicular distance is going to be the shortest distance. So we have the vector here, which is the vector B, so it's the position vector of this point B, and we have a vector which is normal to the plane. That's this vector n here. And we're going to have r dot n equals p, which is the equation of the plane, and then we're going to use this in this formula here. Okay, so here we want to find the shortest distance from the point 133 to the plane that's given here. Now if we remember that n, the normal to the plane, is given by 2 minus 1 minus 2. And this p here in the equation is this value here, so p is 1. The vector b is just the position vector of that point B, so that's 1, 3, 3. So we now want to find out what the distance is, so we just simply use the formula. So it's the modulus of the dot product of b and n, 1, 3, 3, dotted 2 minus 1 minus 2, subtract p, which is 1, and then that's all over the square root of 2 squared plus 1 squared plus 2 squared. That's the magnitude of n. So if we simplify this, we end up with 1 times 2 is 2, plus 3 times minus 1, so we've got minus 1, plus that was minus 7, minus 1. So it's minus 8, but remember it's the magnitude of that, the modulus of that, so we just want 8. And on the bottom, we're going to have 2 squared, so 4 plus 1 plus 4, which is 9, root 9, which is 3. So the distance is 8 over 3. There's a slightly neat version of that you can look through. Okay, so now we're going to do a similar example, but here we've got the plane has been given here in the Cartesian form, and we want to find it from this position vector here. So B, which is our position vector, is just 12, 5, 3. It's always easiest to do these in vector form. N, vector normal to the plane, we can just get from this equation, and that's in previous videos. Minus 1, and p equals 5. So again, it's just a case of substituting these into the equation. So it's going to be b dot n, subtract p, all over 1 squared plus 2 squared plus 1 squared. And if we do this calculation, we end up with 14 over root 6. Okay, please join us for the next video, which is 5.2, the perpendicular distance from a point to a line in 3D.